Hi fellas, this is Chemaddcts again with the solution. Welcome back to another video tutorial. Well fellas, guess what? Now we're gonna solve the second part of this question. So if you have missed the previous part, don't need to worry. I will provide the full solution of this question paper at the end of this video tutorial. So stay tuned and be there with me, okay? So let's start this solution. So let us at first read the question. Okay, let's read the question at first. The table below shows the energy changes that are needed to determine the lattice energy of strontium fluoride. Okay, so this is the energy change is given, and here the value for enthalpy change is given here. Okay, so this is enthalpy change of atomization of strontium, first ionization energy of strontium, second ionization energy of strontium, enthalpy change of atomization of fluorine, half Cl2, first electron affinity of fluorine, enthalpy change of formation of strontium fluoride. Okay, so here at first they have asked us to define the term lattice energy. Fine. So before defining the term lattice energy, let us have a look to the definition of this thing. Okay, lattice energy, in here we can see that it is the energy released when 1 mole of ionic solid is formed from the required amount of gaseous ions. Okay, so why this energy released is, why this energy change is exothermic? That's because the bonds are formed here. Okay, this is exothermic, that's because bonds are formed. Here strontium SR2 plus bonded with chloride ions, these gaseous ions bonded with chloride ions to form strontium chloride, SR2 plus 2 Cl minus. Okay, so in here the gaseous ions, in here the gaseous ions bond together. Okay, bond together to form solid ionic solid, to form ionic solid. Since two gaseous ions bond together to form ionic solid, so this is lattice energy. So we always know that here bonds are formed, and we always know that when bonds are formed, so when bonds are formed, that energy would be released. Since the bonds are formed, the energy would be released, and that energy released is would be the exothermic. Okay, so that is why this lattice energy would be exothermic. Okay, this will have a negative sign, del H lat. Okay, so here the del H lat would have the negative sign. Okay, so now let us get back to the question. Now let us define this thing. Okay, so lattice energy, it is the energy released, the energy released when 1 mole of gaseous 1 mole of ionic solid, 1 mole of ionic solid is formed from the required amount of gaseous ions. Gaseous ions. Since the mark for this question is 2 marks, okay, so we need to mention some of the points to this definition. Okay, so what will be the points? let me mark this with red pen. Okay, don't take it otherwise. Okay, so here this point, this is 1 point. Okay, so energy released is 1 point. So what will be the lattice energy? It will be energy released. So the first point is energy released. So energy released from what? Here, when 1 mole of ionic solid is formed. Here is another point. Okay, so energy released when 1 mole of ionic solid is formed from the required amount of gaseous ions. So required amount of gaseous ion is another point. Required amount of gaseous ions is another point. So we have 3 points over here. So if we mention 3 points, then we gonna secure 2 marks for mentioning 3 points. So 1 point is the energy released when 1 mole of ionic solid is formed from the required amount of gaseous ions. Okay, fellas. So fellas, it would be easier if you break the definition into small parts. So it would be easier to answer if we break this into small parts. So there will be no possibility for missing any points. So just break it down into small parts. The energy released is one part. This is one part. The energy released when 1 mole of ionic solid is formed. This is another part. From the required amount of gaseous ions. This is another part. Okay. So I hope that you have understood how to deal with the definition. Okay. So now let us move on to the next problem. Okay. So in here they have asked us to calculate the lattice energy of strontium chloride. Okay, they have asked us to calculate the lattice energy of strontium chloride. Okay, so here the data are given. That's really good. Thanks for mentioning the data. Okay, we are really grateful for the data that they have given. Okay, happy thankful day, thankful Thanksgiving day. Okay, happy Thanksgiving day to the examiner. Happy Thanksgiving day. Okay, unless examiner is American. Okay. By the way, so here let us have a look to the uh, Born-Haber cycle that is here. So if we have a look here, we can see that the lattice energy is one side. This would be in one side since this is in one direction here. Okay. Uh, Here we can what we can write this in differently, in separately. Okay, and okay, wait a minute. So in here we can see that these are all in one direction band. Okay, so in here these are all in one direction except this formation enthalpy and this lattice enthalpy, and yes, except the formation enthalpy and lattice enthalpy, this all thing will be in one direction. Okay, so let's see. Oh, so in here let us keep the lattice energy in this side. Okay, del h1, since we are finding oh sorry, oh now I get it. Well, let me explain. Okay, don't get confused. I hate when people get confused. Okay, so in here we can see that these are all in one direction. These are all going in one direction except this formation enthalpy. Now I get it. Hooray! Figaro. Okay, just kidding. In here we can see that uh, H2, H3, H4, H5, H6, then H7, these are all in one direction. Okay, and this formation enthalpy is in another direction, opposite direction. So we will write this formation enthalpy in one side and all this thing in another side. So that is how we're gonna solve. Okay, Yahoo! Sorry Google. Okay, so since del H1 is formation enthalpy, we will put this alone. Okay, home alone. Okay, so we will put the other things here. Since formation enthalpy is in one side, in one direction, and the other things in another direction, here these are all in one direction and the formation enthalpy is in the opposite direction, so we will keep the formation enthalpy on the left hand side and all these things in the right hand side. Okay, that's how we're gonna solve. So since del H1 is formation enthalpy, we will keep this as it is. Here we will have del H2 plus del H3 plus del H4, 5, 6, then 7, just like that. Okay, this is formation. Since this is formation enthalpy, so this will be in one side since it is in opposite direction. So this should be in here and all of them is in another direction, so that is why we will keep that in left hand side, right hand side. Since these are all in same direction, so we are keeping this in right hand side. And since this formation enthalpy, since del H1 is the formation enthalpy and is in the opposite direction, the other way around, and we are keeping this in the left hand side. Okay, now let us put the values here. So the formation enthalpy is what? Formation enthalpy is minus 8 to 9. Well fellas, it is required to mention that beware of the signs. Okay, here it is negative sign, so we will keep that as negative. Okay, don't mess up with the signs. Okay, so for the sign, if you messed up with the sign, your answer would be wrong. Okay, so this is as it is. And now let us look at del H2. So del H2, what is del H2? Well, let me mark this thing first. This is del H1. uh, this is del H uh, this is del H1 formation 2, 3, 4, 5, 6, 7. Okay. So this, since this is formation enthalpy, this would be del H1, and electron affinity, uh, atomization del H2, atomization of strontium is del H2. Let me put the values over here that from the diagram. Okay, so here del H3, then del H4, 4, uh, then enthalpy change of atomization of fluorine, enthalpy change of atomization of fluorine is del H5. This is del H5 and del H6. Okay, and del H7 is the lattice enthalpy, okay, that we need to find. So in here, enthalpy change of atomization of strontium is plus del H2, the value of del H2 is plus 164. 164. Then del H3. Del H3 is ionization energy, which is plus 550. Okay. Then second ionization of strontium is plus 1064. Then enthalpy change of fluorine. Well, the enthalpy change of fluorine would be plus 122. So this should be 2 multiplied by 122. I will tell you why. Okay, later on. At first, let us write these things down. Okay. So in here, this would be plus 2 minus, since this is negative, let us write this negative 3, 4, 9, and we need to find del H 7. Okay. So why we have multiplied this thing with 2? Well, as we can see that these are all for 1 mole. Okay, so this happens in 1 mole. This also happens in 1 mole. Okay, this also happens in 1 mole until del H5 all happens for 1 mole. In here, the enthalpy change of atomization of fluorine is 2 mole. Okay, so 2 del H5. So let's see how. Since here two fluorine atoms are formed here. Here two fluorine atoms are formed. So the enthalpy change of atomization will be 2. Here two atoms are formed. So that is why the enthalpy change will be twice. Okay. So in here, since since two chloride atoms are formed, since two chloride ions are formed, here from two chlorine atoms in the first electron affinity, so this should be the twice the first electron affinity of chlorine. Okay, so that is how it is. So don't get wrong here. Okay, most of the student makes mistake over here. They have taken this as 1 and they have taken they didn't multiply it 2. They don't make it twice. Okay, so that's why they will have wrong answer. So if you have calculated this thing, you will get what? Del H7 is equals to minus 2153. Okay, and always be careful with the sign. Okay, and if they have mentioned about the significant figure, don't forget to round this up to the appropriate significant figure. Okay, we didn't round this up to the appropriate significant figure since they didn't mention about the significant figure in the question, so we didn't find it necessary to round this thing up to appropriate significant figure. We are just keeping it like that. And don't forget to mention about the sign. Sign is really important for this type of question. Okay, so the answer would be minus 2153. So fellas, I hope that you have understood the question as well as the answer. Oh, there is one thing that we need to mention, that in here the unit is also important. If they state always state about the unit over here at the end of the calculation, it is a good practice to mention unit. Okay, always mention unit over here. Always mention unit over here. Where is my pen? Yes, always mention about the unit. Okay, in here. So You don't need to mention unit over here since the unit is already given over here. So that's it. That's how we gonna solve this problem. So once again, let me repeat this thing up once again. In here, don't forget to multiply this thing with 2 and this thing with 2, since this doesn't happen in 1 mole. Here 2 moles of 2 moles of fluorine atoms are formed. Since 2 moles of fluorine atoms are formed, 2 moles of fluorine atom. Okay, since 2 moles of fluorine atoms are formed, so here this is for 1 mole of fluorine, so we need to multiply this thing with 2. Okay, in here, since here the value is given for 1 mole of fluorine atoms, so we should multiply this thing with 2 also. Okay, so this should be 2 into del h 5 del h 6. Sorry, this should be del h 2 into del h 6. Okay, so since 2, the reason is 2 the reason is since 2 moles of fluoride ions are formed. Okay, since two moles of fluoride ions are formed, so we need to multiply this thing with 2. So that's the thing over here, that's the main thing over here. So here don't forget to multiply this thing with 2. Okay, since this is for 2 moles and this is also for 2 moles, so don't forget to multiply this thing with 2. Just don't forget to multiply. Okay, here is another thing, that is the signs are really important. Okay, signs are important. So signs are important. Since the signs are important, always consider signs. Okay, always look out for signs. Most of the student makes mistake for not considering the signs and for not considering the amounts. Okay, this is another important thing, is that the amounts, they didn't look out for the moles. Here this is for 2 moles and this is for 2 moles. Okay, so always consider signs and always consider moles. Okay, so fellas, that's it for today. I don't want to make this longer. It is already lengthy video, since we have discussed in details about the problem. So fellas, once again, if you have any question regarding this problem, let me know in the comment section. And stay cool, stay awesome, don't panic. uh, best of luck for your exam, and as always, peace with chemistry.